Hello friends, welcome to the video lecture series on artificial intelligence and machine learning. I am Dr. Dafda, and in this 16th video class of AI/ML, we will understand utility based agents. Starting with the name, why these agents are called utility based agents? These agents are called utility based agents because they rely on a utility function to evaluate and rank different outcomes based on how useful or desirable they are. Okay, see, utility means useful, right? The term utility comes from economics and represents a measure of satisfaction or happiness. Instead of just aiming to achieve a goal like the goal-based agents, utility-based agents go further. They calculate the quality of each possible outcome, which means that they can decide not only what to do, but also the best way to do it by maximizing the utility or happiness score. So, utility-based agents is an expansion of even the goal-based agents. For example, a self-driving taxi agent just doesn't think, can I reach my destination? It also thinks that what is the fastest, safest and most cost-effective way to get there. In short, these agents prioritize actions that maximize the utility function or happiness function, enabling smarter and more balanced decisions just as we humans do. Okay, so let us start. See, the goals alone are not enough to generate high quality behavior in most environments. While goal-based agents focus on reaching a destination, they don't think about how to make the journey better. For example, a taxi agent could take a route that is unnecessarily long or unsafe as long as it gets to the goal, okay, which is not good. So the utility-based agent solves this issue. They rank their choices based on a utility function, which is like a happiness score. And this allows them to pick up not just the path to a goal, but the best possible one, like the safest or the fastest route. So the utility-based agent has many advantages in terms of flexibility and learning. For example, in the case of conflicting goals, okay, like multiple routes for the same destination, and also the cases where there exist several possible goals, like reaching 3 destinations one after the another. Okay, let us understand how utility-based agents differ from simple reflex agent, model-based reflex agent and goal-based agents. The simple reflex agents acts on immediate percept without considering future outcomes. It works only on condition action rules. For vacuum cleaner, if dirty, then clean. Okay. The model-based reflex agent uses internal state but doesn't necessarily aim for goal. For self-driving car, if a car was in the left lane, it is probably still nearby if I can't see it. Okay. The goal-based agents considers future actions based on a goal, providing more adaptable and purpose-driven behavior. For self-driving car, it will move left from the junction if its destination is towards the left. While for the utility-based agents, there are different blocks like utility and how happy I will be in such a state. So in place of condition action rules or goals, here there is a utility block that aims towards usefulness and happiness that has to be achieved. And remember, the goal to reach the destination is always there, right? But here the main focus is on utility instead of goal. Okay, let us understand how utility-based agents work. Like the previously learned agents, here also there is an internal state or memory and the goal reaching block, what it will be like if I do action A. But it also has an advanced block of utility function over here. This utility function has a scoring system that ranks outcomes based on how desirable they are. Higher scores means better outcomes. They do an expected utility calculation where the agent evaluates actions by modeling the environment, that is, understanding the situation, predicting outcome of its actions, and selecting the action with highest expected utility or usefulness. And finally, the action with the highest expected utility is chosen. For example, a self-driving car evaluates routes by considering factors like traffic, fuel efficiency and safety. It chooses the route that offers the best balance of these factors to maximize utility. In short, utility-based agents predict outcomes, rank them, and choose the action that provides the most overall benefit and happiness. Let us see some real-life examples of utility-based agents. YouTube algorithm uses utility-based algorithms to suggest movies or videos. For example, I am watching Sholay movie on YouTube. From my watch history, YouTube knows that I like Amitabh Bachchan movies and that too action movies. So in next suggestions, YouTube will not show me movies like Kabhi-Kabhi, Abhimaan or SilSila. Why? because these are romantic drama movies, and rather YouTube will suggest me movies like Deewar, Zanjeer or Shaan, as these movies are Amitabh Bachchan's popular action movies. Okay, so it uses way factors like user preferences, likings and reviews to recommend the best movies that maximizes the customer satisfaction. So here my preference or utility or happiness is Bachchan sir's action movies. So it will show me such movies. Even the virtual assistants like Alexa or Siri uses utility-based reasoning. Utility-based agents in self-driving cars evaluate trade-offs like speed, safety and fuel efficiency. For example, the car might choose to slow down in heavy rain to prioritize safety over speed. And see, if we consider the same example of self-driving car for all the 4 agents, if there is a roadblock ahead, then for simple reflex agent, it will simply change the route. That is simple condition action rule. If block, then change the route. It will not think that some other car may be nearby. But for model based reflex agent, it has memory of other cars which is coming behind. So it will change the route accordingly. That is, if other car is very near in the parallel lane, it will slow down, allow other car to pass and then change the lane or route. While for goal based agent, it will slow down, allow other car to pass and then change the route in such a way that the next route direction is closer to its goal. While if this car is a utility based agent, it will turn in this direction as its destination is towards this direction. But ahead also, if there are 3 ways or routes or roads to reach the destination, say this is the first route, this one is the second route and this one is the third route, then it will choose the shortest path with less traffic so that the customer happily reaches its destination early. So this self-driving car evaluates routes by considering factors like traffic, fuel efficiency and safety. Okay. Let us see the benefits and limitations of utility-based agents. Utility-based agents are great at making balanced decisions by considering different priorities. For example, a delivery drone might need to decide between getting its destination quickly or conserving battery life. This flexibility helps in dealing with multiple or conflicting goals, especially in uncertain situations. However, designing these agents is tricky because creating accurate utility functions to measure priorities is complicated. Plus, predicting and evaluating all possible outcomes takes a lot of computing power, which can make it hard to make quick decisions in complex or fast changing environments. So in conclusion, we can say that utility based agents are nearly like humans in how they make decisions. They don't just focus on what needs to be done, but also on the best way to do it. Even though they may be complex to design and require a lot of computing power, their ability to make smart and flexible choices makes them very useful in real life situations. So that is all for this video lecture. Thank you very much.